Sixth graders, welcome to Big Ideas Math, Section 9.4, Measures of Variation lesson. Pause while you write Section 9.4 lesson in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is use the range and the quartiles of a data set to describe the spread of a set of data. Today we'll be beginning on page 414 in your math textbook. Example 1. Finding the range. The table shows the lengths of several Burmese pythons captured for a study. Find and interpret the range of their lengths. To find the least and the greatest values, order the lengths from least to greatest. So that's what the book has done for us here. And then the least value is 5. The greatest value is 18.5. So the range of the lengths is 18.5 minus 5, which equals 13.5 feet. This means that the lengths vary by no more than 13.5 feet. Let's move on to example 2 on page 515, finding the interquartile range. The dot plot shows the top speeds of 12 sports cars. Find and interpret the interquartile range of the data. So our first step is to order the speeds from slowest to fastest, which is done for us on the dot plot, and then find the quartiles. So if you remember from yesterday's activity, you find the quartiles by finding the median first, and then you find the median of the lower half of the data and the median of the upper half of the data. So the median of the lower half of the data is called the first quartile, and that is 235, and the median of the upper half is called the third quartile, and that's 255. So the interquartile range is 255, so that's quartile 3 minus quartile 1, so 255 minus 235, and that equals 20. So that tells you how much space there is between these two numbers. So this means that the middle half of the speeds vary by no more than 20 miles per hour. You can use the quartiles and the interquartile range to check for outliers. So any value less than quartile 1 minus 1.5 IQR, so we'll talk about that, is an outlier. So anything that's way down here on the number line is an outlier, and any value greater than quartile 3 plus 150 times the IQR is an outlier. So we're going to use example 3, checking for outliers, to explain what all of that means. So check for outliers in the data set in example 2. So the outlier boundaries are Q1 minus 1.5 times the interquartile range. So, and the upper boundary is Q3 plus 1.5 times the interquartile range. So you need to remember that we calculated the interquartile range up here to be 20. That was right here. And so 235 minus 1.5 times 20 is going to be our lower value, and 255 plus 1.5 times 20 is going to be our upper value. So when we do that math or simplify, we end up with 205 for being our lower value and 285 for being our upper value. So if there was anything lower than that on the left or upper than that, higher than that on the right, those would be outliers. There are no speeds less than 205 miles per hour or greater than 285 miles per hour. So this data set has no outliers. Your assignment for this lesson is to complete the On Your Own problems 1 and 2 below. They are also on pages 414 and 415 of your textbook. Be sure to show your work and be prepared to share during our next class. Please remember, to earn credit for viewing this flipped lesson, you must complete your exit slip, come to our next class prepared with the journal pages or other work from the flipped lesson completed, and be prepared with any work that was assigned in the flipped lesson completed. Be prepared with any questions you have for the teacher, and always have a good attitude. We'll see you next time in class.